All right, in this lesson, we are going to look a little bit more in depth at tree diagrams. So in this lesson, we're going to explore some of the different questions you could be asked about tree diagrams. So here's one question. How many different combinations could there be if we had two different lunch choices, chicken salad and turkey, three different types of sides to choose from, and two different types of drinks? So one way we've talked about before is we could use the fundamental counting principle, and if we had two different types of lunch entrees and then three different types of sides, chips, french fries, or fruit, and then two different types of drinks, so times two, we could just multiply all those different combinations together, the two different types of lunch entrees, three different types of sides, and two different types of drinks, and get 12 different combinations. 2 times 3 is 6, times 2 is 12. We could also count the items at the end of the tree. So if you look all the way to the right side of the tree, it gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different combinations of different things, because at the end of the tree you end up getting all your different combinations: chicken salad, chips, and soda, chicken salad, chips, and water, and so on. So if we count all the items at the end of the tree all the way to the right, we get 12 different combinations. So you could also be asked a question like this: how many outcomes have french fries? So you have to actually follow the tree and figure out all the different outcomes that have french fries. Well, I can see that I could have chicken salad, french fries, and soda, or chicken salad, french fries, and water. So that's two different options. 1, 2. I also could have turkey, french fries, and soda, and turkey, french fries, and water. So those are also two more outcomes that would include french fries. All my other outcomes look like they have either chips for the side or fruit. So chips or fruit. So actually there are 4 out of the 12 possible outcomes that would have, or 12 different combinations that would have french fries. So, and I could reduce that probability to 1/3. So 1 out of 3 have french fries. You could also have a question that asks you about one specific outcome. For instance, let's read this question. What is the probability of randomly choosing a lunch with turkey, chips, and a soda? So let's follow that. So I could choose turkey, then chips, and a soda. So that is one outcome. So turkey, chips, and soda. One outcome out of all the different options. All the different combinations. So the probability would be 1 out of 12. Let's look at this question. What is the probability of randomly choosing a lunch with a soda? Well, we could choose chicken salad, chips, and a soda, chicken salad, french fries, and a soda, chicken salad, fruit cup, and a soda, turkey chips, and a soda, turkey french fries, and a soda, turkey fruit cup, and a soda. So 1, 2, 3, 4, 5, 6, 6/12, or 1/2 of the options have sodas. All right, how about this question? What is the probability of randomly choosing a lunch without chips? So the key word here is without chips. So we do not want chips in our lunch. So we could choose any of these options. Let's see. We could choose chicken salad with french fries or a fruit cup. So any of these options, and then turkey with french fries or a fruit cup. So any of these. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of the 12 would include a lunch without chips, and we could reduce that. Let's divide that in half. 8 divided by 2 is 4. 12 divided by 2 is 6. And then we could reduce that even further to 2/3. 4 divided by 2 is 2. 6 divided by 2 is 3. So 2/3. 2 out of 3. 2/3 is the chance of randomly picking a lunch without chips. All right, so now I have a question. A different tree diagram. I have 3 kinds of shirts, a black, a brown, and a white. And then I can choose from 2 different pairs of pants, black pants or jeans. So I have 3 types of shirts and 2 different types of pants for each shirt. So I can choose from black or jeans. So our fundamental counting principle for probability says that if we have 3 different types of shirts and then 2 different types of pants, that there should be 6 different total combinations. And if we count the end of the tree, 1, 2, 3, 4, 5, 6. There are 6 different outcomes. I'm going to go ahead and list all my outcomes. So sometimes you can draw your sample space. So black shirts and black pants. I'm going to just put black shirt and black pants. And then I could do black shirt and jeans. And I could do a brown shirt. I'm going to do that as BR. BR and black pants. And then a brown shirt and jeans. So brown and jeans. And I could do a white shirt with black pants, so white with black and white with jeans. All right, so those are all my different outcomes. So now let's see, what's the probability? Let's look at our question. What's the probability of randomly choosing an outfit with jeans? Well, I do have 1, 2, 3, 4, 5, 6 different outfits, and let's circle all the ones that have jeans. So let's see. This one, black shirt and jeans, brown shirt and jeans, and white shirt and jeans. So that is 3 out of the 6 total combinations, or 1/2. Could reduce that to 1/2. All right, so the answer is 1/2. Now let's answer this question. What is the probability of randomly choosing an outfit, and I should have said with a black or white shirt. So with a black or white shirt. So, well, I can see that all of these outcomes would have black shirts and all of these would have white. So, let's see, 1, 2, 3, 4. So it should be 4. So, black shirt, yeah, 1, 2, 3, 4. And this is the only one with, these 2 are the only ones with brown shirts. So 4 out of our 6, 1, 2, 3, 4, 5, 6 total combinations, or we could reduce that to 2/3. All right. All right, so now we're going to practice some problems using the fundamental counting principle. So the fundamental counting principle. So the fundamental counting principle says that we can take the number of options, or number of choices for each option, and multiply them together to get our total number of combinations. For example, let me show you a problem. So let's do this problem and I'll show you how it works. So for this problem, if we're going to try to find how many different combinations can be made from a choice of a red, blue, or green sweater. So that's 3 different choices of color. So I'm just going to write 3. So I have 3 different choices of colored sweaters. And then I can choose from a white, black, blue, or tan pair of pants. So 4 different choices of pants. So if I multiplied those 2 together, 3 different choices of sweater times 4 different choices of pants, that gives me 12 different combinations. And so to figure out all the different combinations, I wouldn't have to draw a tree diagram. I can just multiply the number of choices together to get my total outcomes. Let's try another one. So here we have, it's asking again, how many different combinations can be made from a choice of chicken, ham, or bologna sandwich. So that's 1, 2, 3 different types of sandwich times, and let me see, we can choose from a drink, coffee, milk, juice, or soda. That's 4 different types of drinks. So 3 times 4 is 12. So again, we have 12 different combinations of meals. All right, let's try this one. This is a little bit more complicated. So Selena is ordering matching shirts for the tennis team. They can get t-shirts or turtlenecks. So that is 2 different types of shirts. And each type of shirt comes in, let's see, red or orange. So that's 2 different colors. And then they can, oops, let me erase that. They can get either a logo can be shaped like a cube, pencil, or cat. Cube, pencil, or cat. So that is 3 different types of logos. So if we multiply those different choices together, 2 times 2 is 4. Then 4 times 3, again, we have 12 different combinations that Selena has to choose from. All right, how about this one? See if you can do this one on your own. All right, let's see if you got it right. Juan is putting together his lunch. He can't decide whether to have a peanut butter sandwich, a ham sandwich, an Italian sub, or a tuna sandwich. He can take an apple, an orange, or a banana as his fruit. How many different combinations can Juan have for lunch? All right, so he can have a peanut butter, ham, that's 2, Italian, that's 3, or tuna salad, that's 4. So that's 4. And then he can take an apple, orange, or banana. So that's 3. Gosh, again, we have 12 different combinations. All right, let's try this one. Hopefully it's not 12. Paula is ordering a burrito for lunch. She can have beef, fish, or black bean burrito. Then the wrap choices are sesame seed, sourdough, or whole wheat. Then she can pick avocado, tomato, or lettuce as a topping. So how many different combinations can Paula order? Why don't you try this one again on your own too? All right, so let's figure this out together. She can have beef, fish, or black bean burrito. That is 3 times, let's see, wrap choices are sesame seed, sourdough, and whole wheat. That's 3 again. And then she can pick for topping avocado, tomato, or lettuce. So that's 3. So let's see. 3 times 3 is 9. Then 9 times this 3 is 27. So there are 27 different combinations. All right. Now, if she chose to pick, let's just say beef. So if she picked a beef burrito with whole wheat, I'm just going to say WW, and then she wanted tomato, which I'm going to put just T for topping, for tomato for her topping, then that is just one combination, one distinct combination out of the 27 different ones. So that would be, if she picked that at random, that would be 1 out of 27 of a possibility that she would choose that one. All right, let's see if you can do this on your own. So the question is, what is the probability that a striped or solid shirt would be picked with blue jeans? And this would be, let's say that someone was picking this for you at random. So a striped, what's the probability that they'd get a striped or solid shirt and blue jeans? So see if you can figure out that probability.
Alright, here's Corey trying to have some fun. Please don't take trash. Uh-oh. Good, he lived.